The next topic in mathematics that I want to cover is algebra and linear algebra. And first of all, we'll look at complex numbers and logarithms, and then matrices and determinants. So first of all, in complex numbers, the definitions of complex numbers are given here, and the definition is z, a complex number, is equal to a plus jb, where in that equation a is the real component, and b is the imaginary component, and j is the square root of -1. Although many disciplines, and more commonly, I is used instead of j. But here we'll use j just to follow the notation of the handbook. So a complex number can be displayed in terms of the diagram which is shown here, which is sometimes called an argand diagram, where the horizontal axis is the real axis, or the value of the real component, or the real part of the imaginary number, and the vertical axis is the imaginary axis, which shows the magnitude of the imaginary part. So the point here, z, is a plus jb, and this can also be expressed in polar form, where the radius here is c, and the magnitude of the radius is just equal to the square root of a squared plus b squared and the angle theta. And manipulations on complex numbers can be performed fairly easily. For example, the summation of two complex numbers, z1 is a plus jb1, z2 is a2 plus jb2, then to sum those equations, we simply add up the real components and add up the imaginary components as shown here. In the polar coordinate system, we can express it like this, where r is the radius or the magnitude of the vector or the imaginary number, and in this case we have r is equal to cosine theta, and x is equal to r cosine theta, and y component is equal to sine theta, etc. And the rest of the equations as given here. Another convenient form to express this in terms of Euler's identity, exponential, or e to the j theta, is equal to cosine theta plus j sine theta, is another way to express the complex number. So let's do an example on that. The polar coordinates of a complex number are magnitude 4 and angle 56 degrees. Its rectangular components or coordinates are most nearly which of these? So here we simply use the definitions that x, the real component, is equal to r cosine theta, is equal to 4 cosine 56 degrees is 2.24. Y, the imaginary component, is r sine theta, which is equal to 4 sine 56 degrees, is equal to 3.32. So the answer is C. And you can also always confirm for yourself, if you want, that indeed the magnitude or the radius is equal to the square root of the sum of the squares of those two components. Next we look at logarithms, and the basic definition of the logarithm of a number, say x to the base b, is written like this: log of b of x is equal to c, where b to the raised to the power c is equal to x, is the definition of a logarithm of base b. And in particular, most commonly we use so-called natural logarithms, written as ln of x, which is a logarithm raised to the base e, and also logarithms to the base 10, usually written as log without the subscript 10, is written like that, are the most common ones. To convert the bases of two logarithms, we have this equation here: log b of x is equal to log a of x divided by log a of b. So for an example, we're given that the log of 6 is 0.778 and the log of 8 is 0.903. And because the base is not given here, it's implicitly implied that this refers to log to the base 10. The question is, what is the value of log to the base 6 of 8 out of these four alternative answers? So we use our general equation for converting between bases. log b of x is equal to log a of x divided by log a of b. So in this case we have log b of x is equal to log 10 of x divided by log 10 of b, where x and b are the two values that were given. So logarithm to the base 6 of 8 equals log to the base 10 of 8 divided by log to the base 10 of 6, which is equal to the given values of 0.903 divided by 0.778, which is equal to 1.161. So the closest answer is A. And this concludes our discussion of logarithms.